Hello. Uh, Good evening, one and all. Am I audible to everyone?
Yes.
Okay, fine. Thank you. Uh, Yesterday, we have discussed about some design basics according to AISC code, but some of the people are asking to discuss about Indian standard codes. So, first of all, in today's new topic, that is load calculations. Let us start with Indian standard code only. I will tell you the design calculations according to AISC code in the later class. So let us start with Indian standard codes. First of all, in the last class we have discussed about some design basics, and today we are going to discuss about some load calculations, how to calculate any load. Prior to going to learn about load calculations, we have to learn some terminology regularly uses in the PEB structure. So for that purpose, I have one drawing. I'll show you and I'll explain you the basic terminology which is useful in a PEB structure. Okay, fine. I think my screen is visible to all of you, right? I think that as confirmation. So I'm proceeding with the today's topic. So basically here a PEB plan, I'm showing you a PEB plan that is a column layout at the base plate level. So here you are seeing some columns which are rounded here, that is called mezzanine columns. These columns will be go up to the mezzanine only. They will not go to the entire. Fine. Okay. Here you are seeing a BC structure, BC1. So if you cut the cross section at any point at this mezzanine level, you can see the cross section will be like this. Only one column is going up to the roof, that is internal column. We can call this as BC1 frame. Okay, this is the mezzanine. These are the mezzanine columns we are talking about now. These mezzanine columns will go up to the mezzanine only to support the mezzanine beams. And this is the basic structure. In the terminology, we are discussing the frame, the length, the width of the PEB will be taken along the frame line. So the width of this building is 55 meters, that is along the frame line only. Perpendicular to the frame line, we can call it as length, that is I'm showing here 84.5 meters. Okay, the width of the building will be along the frame line, that is I'm showing you one drawing here. The width of this building in the drawing is 55 meters. The perpendicular is the length 84.5. And this is about width and length. While talking about the height, there are some certain terminology we are going to use in PEB. One is eave height. Eave height is nothing but the height up to the top of the channel section, which is called eave strut. I have already discussed in the PEB components. The C section you are seeing here, right? The C section is called eave strut. For the top of eave strut from the bottom level, you can call it as eave height because the height is up to the eave strut only. So you can call it as eave height, and the peak point in the building can be called as the ridge height. Okay, eave height is nothing but at the edge of the building from bottom of the building to the top of the eave strut. That is eave height. From bottom of the building to the top of the peak point of the building, you can call it as ridge height, whereas the net distance between bottom of the floor to the below the rafter is called as clear height. Okay, the height from bottom of the floor to the below of the rafter is called a clear height. And the other thing, base spacing. Okay, every building has some columns at a particular interval. That interval is called as base spacing here. Suppose for this bay, the base spacing is 4.45, this bay 6.3, for this bay, base spacing is 7.5. So the interval between the frames can be called as base spacing. 7.5, this is like this. These are all base spacings, right? So here we have to design 13 number of frames. 1, 2, 3, 4, and something. We have to design 13 number of frames here. And every PEB building should have a particular slope, should have a minimum 4% of slope, nothing but 4 in PEB, minimum 4% of slope to drain the rainwater easily. Okay, so this is the roof slope. We can call it as roof slope. And yeah, next coming to this, the end frames, nothing but you can see here grid line 1 and grid line 13. You can call the frames along grid line 1 and 13 called as end frames. Basically, end frames are of two types. One is main end frame and other one is light end frame. Main end frame is nothing but there will be no bracing allowed between the internal columns. In that case, we can call it as main frame. Otherwise, we can call it as, if the bracing is allowed. Generally, why we provide bracing? We have to provide bracing for control. So if we provide bracings here, the sections will be lighter. That's why the end frame with bracings can be called as light end frame. Otherwise, it can be called as half bay loaded main end frame. In case if there is any future extension, in case if any customer wants to extend the building in future, we have to design it for full load width. So what is meant by a load width? Suppose, for example, I am taking this frame. So this frame I am taking. Okay. So for design of this frame, what will be the load width I have to design? So this is a simple one you have to learn. This frame takes load, half of the load from this base spacing and takes half of the load from this base spacing. So basically the load width for the frame, this frame along grid line 5, you can say along grid line 5, the base space, the load width or the tributary, you can say tributary of the frame is 7.5 meters. How it will be 7.5? The half of the this base spacing, half of the this base spacing. So this will be the effective tributary for this frame. This will be 7.5 for this frame. You have to take 7.5 meter tributary to design the loads on this frame. Okay, and the next other thing you have to know, side walls. The walls along the length can be called as side walls. The walls along the width can be called as end walls. Always you have to use a particular terminology. This is the width I am talking, this is the length. So the walls, these are the walls, a perimeter of the building. So the walls along the length of the building can be called as side walls. The walls along the width of the building can be called as end walls. These two are end walls and these two are side walls. So based on this terminology, I'm going to explain how to calculate loads. Suppose dead load and live load. There is no calculation for any dead load and live load, whichever is given by the customer. We have to take the dead load and live load. But whereas while coming to the seismic and wind, there are some particular calculations. But code we have to follow IS 1893. The latest version is 2016 here. I'm using IS 1893 2016. Why we are using IS 1893? This is the basic question you'll get. So we are using this IS 1893 code to get the base shear. Nothing but we are going to design the foundation to resist earthquake also. Basically, all the PEB structures are to be designed to resist earthquake and wind pressures also. So we have to know the particular base shear. What is meant by a base shear? So whatever the lateral force coming due to earthquake at the base of the structure. Suppose okay, suppose this is the base of the structure, right? At the base of the column, whatever the lateral force coming onto the structure at the base of the structure due to seismic activity, that can be called as a base shear. So the lateral force coming at the base of the structure due to seismic activity can be told as base shear. So how to calculate a base shear according to IS 1893? Here I have provided, I have prepared one Excel sheet by taking an example. Okay, first of all, let us take an industrial warehouse is required by customer at a Bangalore city. So why I am using this example, you know, what is the purpose of the building also we required here. So when we require, I'll let you know. So industrial warehouse, for example, we are designing an industrial warehouse at a Bangalore city. So for example, the length of the building is 30 meters. The width of the building means nothing but the dimension along the frame line is 20 meters. EU height is 6 meters. Suppose let us take, and the roof slope is 1 in 10, and the dead load from sheeting and purlins is 0.3. Live load is 0.6, nothing but 30 kg per meter square and 60 kg per meter square. Suppose these are all assumed data. I'm taking all these are assumed data. I have taken to explain to calculate the base shear. So from clause 7.6 of IS 1893, suppose let us go to IS 1893. Where is that clause? Clause 7.6. Here, the design base shear along any principal direction of a building shall be determined by VB is equal to AH into W. So there are two components you have to learn before calculating the base shear. What are those components? So AH is design horizontal acceleration coefficient and W is the seismic weight of the building. Seismic weight of the building is nothing but it is a force. A part of the force can be called as base shear here. So AH is nothing but it's a simple factor. So how to calculate AH? So AH is as per 6.4.2. Here all the things you can find in code. So AH can be calculated as per 6.4.2. So 6.4.2, let us go to 6.4.2. Here, the design horizontal seismic coefficient is defined as AH is equal to Z by 2 into SA by G divided by R by I. Every variable has a particular meaning here, whereas Z is nothing but zone factor, seismic zone factor. It depends upon the building place, nothing but where it is located. And for calculating SA by Z is nothing but design acceleration coefficient. SA by Z is design acceleration coefficient. To calculate design acceleration coefficient, we need one more parameter, that is natural time period. natural time period. Natural time period can be defined as per clause 7.6.2. Just most of you will get confusion all these looking at. If you want, I'll provide this Excel sheet to you so that you will get clear idea how to calculate design base shear. So to calculate design base shear, we need design seismic horizontal coefficient. To calculate design horizontal seismic coefficient, we need zone factor and design acceleration coefficient. R is nothing but response reduction factor, whereas I is about importance factor, depending upon the usage of building, purpose of building. Okay, so first of all, zone factor. How to choose zone factor? Suppose there is table 3 in IS 1893. Okay, table 3 is seismic zone factor. So to calculate seismic zone factor, we need seismic category. So which zone? Suppose let us take in this example, we are designing a building at Bangalore. So Bangalore comes under which zone? You have to know it from the seismic map, right? IS 1893 provides a seismic map of India. You can see it in page number 13 of IS 1893. Suppose I am designing the structure at Bangalore. Here you are seeing Bangalore, right? So it is blue shaded area. So blue shaded area in the legend, you can find blue shaded area represents zone 2 only, right? So Bangalore seismic zone is zone 2. So in table 3, so for zone 2, zone factor is how much? This is 0.1. So let us take that as 0.1 here, right? And to calculate design acceleration coefficient SA by G, we need natural time period. So how to calculate time period? Clause 7. So let's go to clause 762. Yes, 762. This is the time period for different types of structures. For RC MRF building. So what is MRF? This is not a tire company. Moment resistance frame. Moment resisting frame. MRF nothing but moment resisting frame. For RC MRF, we are going to use steel here. So this case is not applicable. And RC steel, nothing but composite sections they are talking about. So this is also not useful in our PEB use. So for steel MRF building, steel moment resisting frames. So this is the formula which is applicable in fundamental time period calculation. So TA is nothing but 0.085 h to the power of 0.75. I have provided a formula here. So what is h? H is nothing but height of the building. What is the height of the building here? 6 meters you can see. I have assumed the height of the building is 6 meters. So I am applying that formula 0.085 into h is nothing but this one to the power of 0.75, right? Approximately the time period we got is 0.325 something. So this is in seconds. Since it is the time period we are talking about, the value we got here is in seconds. So 0.325 or nothing but 0.
Sir,
no,
the average.
I need EU height is sufficient. Okay, EU height for buildings less than 18 meters for the this is according to the practical. You know, there is nothing mentioned about steel stress can see, suppose I'm talking IS 18, so I'll show you about which 6.2. Yeah. Yes. So this is the height of the building. They have provided one figure to find out the height. See figure number 5, they have mentioned, right? So let us go to figure number 5, what they have shown in the code. So this is the frame. They are talking about. These are the frames. All these you can observe, all these are rectangular buildings. So there is no need of any triangular portion, right? So they are talking just height above the ground level like this. So for steel buildings, there is no particular mention in this code. So we have to take the buildings having U height below 18 meters, we can take U height as H. For buildings above 18 meters, you have to take the mean height, nothing but U height plus ridge height divided by 2. Are you clear now?
Yes, thank you, sir.
Okay, fine. Any other doubt? So I'm going to proceed further.
Just one more thing, sir.
Yes, tell me.
That since the dead weight in PEB structures will not be that much, so will the seismic load will be very significant, or is it going to be significant or not?
Yes, exactly. The point is that dead load on the structure is not that much. So,
yeah.
For suppose if we take a mezzanine inside the building.
Yeah.
For suppose, let us take a mezzanine inside the building, like I have shown here, like this.
Yeah, but so, that mezzanine. Okay.
Yes. Okay, fine. So this is the concrete slab, right? Mezzanine will have a concrete slab.
Yeah.
So obviously the dead load of the concrete slab will be more, right?
Okay.
So in that case, it will be significant. For generally, for less height structures, it will not be much significant. Fine. Just I'm getting some disturbance here. Okay, fine. Thank you. So I got natural time period T as 0.33 approximately. Let us take 0.33 seconds. So for this 0.33 time period, what will be the SA by G value? That is design acceleration coefficient. So design acceleration coefficient is defined in clause 6.4.2. So let us go to clause 6.4.2. 6.4.2. Yes. So here you have seen SA by G for different types of time periods, right? For using equivalent static method, generally we follow this method only in PEBs, equivalent static method. So the customer should mention the soil condition at the site. Otherwise, if he did not mention anything about the soil condition in the site, generally on an average, we will take medium stiff soil. Okay, understand? The customer himself should mention the condition of the soil, whether it is medium stiff or loose soil or a hard rock soil. Otherwise, he did not mention anything. If he did not mention anything in the request form, we have to take medium stiffness soil. That is not much that hard as rock, not that much loose. So we have to go for on an average medium stiffness soils in the regular practice. So what we got time period 0.33, right? So this 0.33 ranges in between 0 and 0.55 seconds. So T value is in this case only, right? So what will be the SA by G value? 2.5, right? 2.5, because we got T value 0.33 seconds. So what 0.33 is ranges in between 0 and 0.55. So we have to take 2.5 as SA by G value. So that is, I'm taking here 2.5. And then next coming parameter is response reduction factor. So how to calculate response reduction factor? Response reduction factor will be taken from table number 9. So what is table number 9? We'll see here. So table number 9 is here, response reduction factor for building systems. Okay. So what is the type of frame we are using here? RC buildings with OMRF, RC buildings with special moment resisting frames, steel building with ordinary moment resisting frame, and steel building with special moment resisting frame. Generally, we take steel buildings with ordinary moment resisting frame. Generally, in this in any fixed case, if there is any particular stiffness, we provide the, we can take steel buildings with special moment resisting frames. But general case, we follow steel buildings with ordinary moment resisting frames. That is 3 here. You can observe moment resistance frames 3, R value 3. So I'm going to note down 3 here. And the importance factor I. So how to take importance factor? It is defined in table 8. So if we go to table 8 here, so this is the importance factor of the structure. So how to calculate importance factor? So important service and community, for example, here you can see something, all these buildings like hospitals, telephone exchanges, television stations, because all these are for emergency. Suppose if any flood comes here, there should be some hospital, there should be communication between the people for telephones, there should be one transmission system like television, radio stations, and rails and roads, etc. So all these comes under high importance structures which having coefficient importance factor of 1.5, and residential comes under importance factor of 1.2. All other buildings you can take importance factor as 1. Since we are taking here example in industrial warehouse, so this not comes under case 1 and 2. So we have to take importance factor as 1 here, right? I is taking, I'm taking 1. Fine. So all these parameters now we have done here. So now we have to calculate AH, nothing but design horizontal seismic coefficient. So the formula is Z by 2 into SA by G divided by R by I. So I'm just using my formula Z by 2. Z is here divided by 2 into SA by Z. I have got 2.5 here, right? Divided by R is nothing but response reduction factor 3 divided by importance factor. So what we got? AH is nothing but horizontal seismic coefficient is 0.041667, nothing but you can take it as 0.042. Fine. I think everyone is clear about this. So this is the calculation part of design horizontal seismic coefficient. Now our aim is to determine the design base shear at the base of the structure. So this is AH into some particular weight. What is that weight? Generally, W is called as seismic weight. So to calculate seismic weight, we have some formula defined in the class 7.4. So this is the class I'm going to show you 7.4. Here, seismic weight of floors. So what he has written in this. So seismic weight of each floor is its full dead load. Full dead load. You can observe full dead load. Nothing but dead load. I have mentioned here, you can see formula. Dead load plus appropriate amount of imposed load. So appropriate amount, he has mentioned appropriate amount of imposed load. So we are not going to use entire live load. Imposed load is nothing but live load, right? So we are not going to use full amount. There should be some percentage of amount imposed load we are going to use. So this is the formula they have given. So why you have mentioned tributary here, tributary area here. So seismic weight. So this is a force or a load. So which should be in kilonewtons only. Whereas our dead load and live load are in kilonewton per meter square, right? So these are aerial loads. Generally we call them as aerial loads. If the unit of the load is kilonewton, we can call it as point load or concentrated load. If the unit of the load is kilonewton per meter, we can call them as uniformly distributed load or uniformly varying load depending upon the situation. And these are kilonewton per meter square loads, nothing but we can call them as aerial loads. So that's why I have provided a tributary area, because the seismic weight should be in kilonewtons only. So what is meant by a tributary area? For example, to calculate tributary area for a frame, suppose let us take this frame. Though I have not provided this an example, but how to calculate tributary area I'm showing here. So the tributary I have shown here, this frame will take half of the load from this one, half of the load from this one. So 7.5 plus 7.5, 15 divided by 2. So the tributary of the building is 7.5 here. Suppose in our scenario, what is the base spacing I have given? Sorry, this suppose, for example, an easy calculation. Let us take 6 at the rate 5 meters, nothing but 5 plus 5 plus 5 plus 5. So the base spacing is like this. So total 6 number of 5s are there. So obviously the tributary will be 5 meters here. So tributary area I am mentioning. So the obviously I have provided tributary 5 here in the scene, and the width of the building here, nothing but area is nothing but width into length. Width is nothing but how much we have taken in an example. Here width is 20 meters and tributary is 5 meters from here. So this contributes tributary area. In this calculation, we have to know another point. Generally, we need not to take entire live load, because I'll show you one clause here. Sorry. Yes, if you see clause 7.3.2, I'm telling you again, clause 7.3.2, if you observe this, for calculation of design seismic forces of buildings, imposed load on roof need not be considered. So according to our formula, dead load plus some percentage of live load into tributary area, right? dead load plus some percentage of live load into tributary area. But if there is no mezzanine in the structure, for example, we are taking a simple structure here. There is no mezzanine, only one roof will be there. So what he mentioned in the code for calculation of design seismic force of buildings, imposed load on roof need not be considered, right? Imposed load on roof need not be considered. So here live load contribution will be 0 in this formula, right? So only dead load we have to take. Dead load is how much? We have taken 0.3 into. So tributary is how much here? I'm taking base spacing as 5. So tributary will be 5 into tributary area I'm mentioning. So width into length. Here width is 20 meters, length is 5 meters for one frame only. I'm talking about one frame. So width is 20 meters otherwise, right? So this is the seismic weight of the structure. This is in the units of this 0.3 is kilonewton per meter square. We are multiplying tributary area, so meter square will be gone. So the remainder is kilonewtons, right? So seismic weight of the building you got is, seismic weight of a particular frame, of only one frame I'm talking about here. So that is you got is 30 kilonewtons. Now we have AH here and we have seismic weight here. So design base shear will be AH into W as mentioned in class 7.6 I have shown previously. So AH we got here into seismic weight we got 30. So that gives you 1.26 kilonewtons or 1.25 kilonewtons, right? I think all of you got this. So this is how we have to calculate the design base shear. And then the other particular calculation we have to know is wind calculation. So wind calculation for seismic calculation we have seen IS 1893 2016. So for wind calculation we have to follow IS 875 Part 3. Recent version is 2015. So I'm taking the same example, which is the industrial building at industrial warehouse at Bangalore. I'm taking the same house for same data for wind load calculation also for your understanding. So I think someone unmuted. Is there any doubt? No? Okay, fine. So before going into the wind pressure calculation, we have to take basic wind speed at that particular area. So we have seen, we have taken example at Bangalore, right? So what is the basic wind speed at Bangalore? So if we go to IS 875 Part 3, there is one wind map. So this is the map of India showing basic wind speed. So I think all of you know have some idea about this one. So suppose let us take our site is at Bangalore. Here you can observe Bangalore. This, if you observe this one, this is blue colored shaded area, right? Something navy blue, light navy blue colored shaded area. So we have to go for legend. So light blue colored shaded area is having 33 meters per second basic wind speed. Okay, we have 33 meters per second basic wind speed here. So I'm going to note that one basic meters per second. So for the calculation of design wind pressure, we need to calculate design wind speed. So how to calculate design wind speed? So there is one class in one class 6.3 in IS 875 part 3. So this is the class, okay, design wind speed VZ. So VZ can be defined as the basic wind speed with some particular factors. Those are factors K1, K2, K3, K4. So what are those factors K1, K2, K3 and K4? So the probability or risk coefficient, K1 is nothing but the probability factor or risk coefficient. So to calculate probability factor or risk coefficient, we have to go for class 6.3.1. Fine. So 6.3.1. Actually they have given risk coefficient K1 factors in table 1. So let us go to table 1 to calculate the value. Where is the table 1? So this is the table 1 for risk coefficient of different classes in different wind zones, right? So all general buildings and structures, temporary sheds which is having only 5 years design life, and buildings and structures low degree of hazard which should be designed for 25 years of design life, and important buildings such as hospitals, power plant structures which have a design life of 100 years. So our warehouse structure will come as all general buildings, right? So there is no temporary structure, no mention of any low degree hazard. We cannot mention it as low degree hazard because an industry will have a certain labor, right? So more number of labor will be there. So if anything happens in that industrial area, so that will cause a major damage. So this is not low degree hazard, and this is also not that much important building like hospital. So this is not a temporary building. So we can leave these three cases. The remaining one is all general buildings and structures which has a design life of 50 years and having one risk coefficient is 1 because our wind speed is 33 only, right? So for Bangalore we have noted here already basic wind speed is 33. So for that you have to take K1 as 1. So I have noted it here. And the second one K2 is terrain roughness factor. So terrain roughness factor which is mentioned in table 2. So table 2, let us go to table 2 here. Factors to obtain design wind speed with different height. So generally what is the height of our building? So our building is having U height of 16 meters. So which is less than 10 meters. So basically all these values are starting from 10 meters only. So there is no lower value. So we have to take 10 meters itself. For 6-meter building also you can take 10 meters because if there is any other thing below the 10 we can interpolate. But there is no other thing lower than the 10 meters they have mentioned. So we have to take this one only. So what is terrain category 1, terrain category 2, 3 and 4? So if you look at these terrain categories, category 1. So exposed open terrain with few or no obstructions. Category 1 is completely exposed to the wind. There is no other structures like in desert areas, etc. like that, right? So, and the category 2 is open terrain with well scattered obstructions having heights generally between 1.5 to 5 meters. So the buildings around our building, our assumption, nothing but the buildings around our building will be having heights of 1.5 to 10 meters like that. In case like that, the category falls under category 2. If there is some mixed like that 1.5 to 10 meters of some buildings and there are few large buildings, that comes under category 3. And if that is well developed area having all are large buildings, only your building assumption is very small, in that case you can take it as category 4. So obviously category 1 will be of higher value. So if customer did not mention anything, we go for category 2. So what is the category 2? So category 2 value for 10 meters is 1. So we have to take K2 value as 1. Okay, and then go to topography factor K3. So K3 is mentioned in class 633. Okay, this is topography factor. So here you can observe the effect of topography shall be significant at a site when the upwind slope is more than about 3 degrees. So upwind slope, nothing but upwind slope if there is any hill or any valley, so the wind direction will be changed, right? The wind may travel inclined, otherwise it will be horizontal always. If there is any hill or any valley at that side, the wind direction will be inclined, so otherwise it will be horizontal with 0 degrees. So for our assumption, there are no hills at our side, so we can go for the value of K3 may be taken equal to 1. If you go through class 6331, you can observe this point. The value of K3 may be taken equal to 1 for 0 degree wind. So I am taking this value as 1. So and the K4 is cyclonic importance factor. So this is mentioned in class 6.3.4, cyclone importance factor. Yes. So they have given some particular table like one here. Structures of post-cyclone importance for emergency shelters, hospitals, schools, communication towers, etc. We have to take that K4 value as 1.3. Industrial structures as 1.15. All other structures as 1. So so we are dealing with an industrial warehouse. I have mentioned here the purpose of the building as industry. So it is since it is a industrial warehouse. So we have to take K4 as 1.15. So 1.15, right? So obviously VZ will be K1 multiplied by K2 multiplied by K3 multiplied by K4 multiplied by VB. So that is equals to this one into this one into this one into this one into basic wind speed, K1 into K2 into K3 into K4 into basic wind speed. That is the formula we have given in 6.3 class. So we have got VZ, nothing but design wind pressure, we got as 37.95 meters per second. Basic is 33 meters per second. We have design wind pressure as 37.95 meters per second. So this is some part completed. So we have to take wind pressure at height Z. Suppose PZ. This value is given as 0.6 VZ square according to class 7.2. So design wind pressure. To calculate design wind pressure, we have to know first wind pressure at a particular height or datum level. You can call it as datum. A particular datum, it has PZ, right? PZ is equals to 0.6 VZ square. We have VZ here, right? VZ is 37.95. So from that, we are calculating 0.6 into VZ square. So 864, the units of this one is Newton per meter square. So other thing you can call it as Newton per meter square, you can call it as pascals, right? 1 pascal is equal to 1 Newton per meter square. So here you can observe the meters, the units of the PZ, Newton per meter square. Wind pressure at height Z, nothing but at datum Z is Newton per meter square. We got 864.1215 Newton per meter square. So let's calculate the design wind pressure PD. In this class itself, they have mentioned PD is equals to KD, KA, KC into PZ. So what are these KD, KA, KC? So KD is nothing but a wind directionality factor. KA is nothing but area averaging factor. Nothing but combination factor. So according to class 7.2.1, so the wind directionality factor is here. So if you see, it is specified that for buildings, clearly observe, for buildings, solid signs, open signs, lattice frameworks, and truss towers, triangular, square, or rectangle, a factor of 0.9 may be used on the design wind pressure. For circular or near circular forms, nothing but you can observe circular and near circular means dome type structures like mosques. Generally, mosque you can observe in the mosque at the top of the mosque you can observe a dome-like structure. At that point, you have to take 1. Otherwise, you have to take 0.9 only, right? So you have to take 0.9 only here. KD is 0.9. This is a factor. Factor will not have any units. Be clear, right? Factor will not have any units. So this is 0.9. And the other thing, area averaging factor 7.2.2 and table 4. So table 4, they have mentioned tributary area. So based on tributary area, what is tributary area? Just base spacing into width of the building. What is our base spacing? It is 5 only, right? So 5 meters into width of the building. 5 into 20, how much? It is 100, right? It is 100 meters square. Sorry, for 100 meters square, for greater than or equal to 100 meters square, we have to use 0.8, right? 0.8 as area averaging factor, Ka value. So I am taking this as 0.8. So our tributary is 100, right? 20 into 5. Do you have a clear idea? Just I have told you tributary area in previous itself. In seismic calculation, I have noted down here tributary area. That the same tributary area I am using here. So, okay. Again, I'm telling you, don't confuse. Okay, the tributary is nothing but the load width. How much area to cover to take the load by a frame? That is called a tributary. How much length of the building to take load by a frame, right? So in this it is half, in this it is half, so it will be 7.5 in this case, but in our case these are 5s, right? So the tributary length will be 5 and the width will be in our case 20 meters. So 5 into 20, which gives you 100. In 100 meter square area, sorry, for greater than or equal to 100 meters square, we have area averaging factor Ka as 0.8. That thing I have mentioned. The last one, combination factor Kc. This is mentioned in case class 7.3.3.13. 7.3.13. 7.3.13. You can observe class here 7.3.3.13. So when taking wind loads on the frame cladding, it is reasonable to assume that pressure, suction inside and outside fully calculated. So therefore, when taking the combined effect of wind loads, combined effect means nothing but pressure and suction. There may be some differences in taking pressure and suction. So a reduction factor of 0.9 may be used for the building element when roof is subjected to pressure and internal suction. Pressure and internal section or vice versa. So in that case, we can use Kc 0.9. 0.9 I'm mentioning here. So we have Kd, Ka, Kc. So the design wind pressure is Kd, Ka, Kc into Pz. So that is equals to Kd into Ka into Kc into Pz. This one, right? So 559.95 something, right? 559.95. 95 Newton per meter square. So, but there is another last class you have to see. This is the more important one. Okay, this is the last important point. You have to note that the value of PD in the class 7.2 itself, design wind pressure class. There is one design wind pressure class we have discussed, right? So in that clause itself, the one point is here, the value of PD, design wind pressure, however, shall not be taken less than 0.7 pz. 0.7 pz. So in any case, PD shall not be less than 0.7 pz. That is 0.7 into pz value is here 864 we got. So 604 Newton per meter square, right? We have to take larger value between these two, right? We have to take larger value between these two. So final value will be this one only, right? 0.7 pz, because this is 559 and this is 604, right? So what is the larger value in between them? So this is 604 only. So is equals to max of this one comma this one. So this is 604 point. So this is the maximum value in between these two. So 604.8851 Newton per meter square. Generally in metric units, if meters is there, we have to use kilonewtons only. So here it is newtons. We have, if we want to take it as kilonewton, we have to divide this by 1000, right? So this is 0.604605 kilonewton per meter square. This is all about a wind pressure calculation, right? Everyone got it, right? Do you have any doubts in this class regarding all this? How to calculate wind pressure, and seismic base shear, and what are the components, what are the terminology you have used here? Just anyone, you can ask me.
Sir, one question, sir.
Yes, exactly.
Same thing can be applied to steel, instead of this steel structures also, for example, G+2 or G+3 building.
You mean to say G+2 or G+3 steel structures only, yeah?
Yes, sir. Same principle can be applied. Wind and
yes. For wind, everything the same, but the seismic will change. Because I have mentioned only, it is only for one floor, right? I have mentioned here only for one floor. You have to add seismic fate for other floors also. Okay, like sir. This is the only process. There is no change in tributary area. There is no change in dead load and live load, because I have taken zero live load because it has only roof, right?
Yes, sir. Yes, sir.
You are asking about some 2 to 3 floors. You are asking about. So exactly, in that case, sir, we have to take live load into account. So that percentage is mentioned. I'll tell you. To take. Suppose if you go to IS 1893 table 10. Okay, table 10 up to and including 3, you can take 25% of live load if the live load is above 3 kilonewton per meter square. If the distributed floor loads is above 3 kilonewton, floor loads are nothing but dead load plus live load. Don't be confused. If the value exceeds 3, we have to take 50% of live load into account. So this is the thing you have to add. Wind wise, it is same. There will be no change. Any other thing? And there are some doubts. Difference between, yes, exactly, difference between ordinary moment resisting frame and SMRF is nothing but special moment resisting frame. So ordinary moment resisting frame is nothing but the frame which allows some sway. Special is nothing but special moment resisting frame. There will be so much control. There will be negligible control, negligible in sway values. That is the main difference. So it can control sway more. Because they'll use some type of springs at the top of the structure by imparting some stiffness at the top. No, and the legs and please explain the load calculations. What is this? Yeah, I'll explain for sure. For sure, I'll explain AC chord load calculations also. Don't need not to worry about this. Just in one day I can explain only one thing, no, right? In this I have completed AIC code. In the next class, surely in this class I have explained about IS codes, seismic and wind calculations. And one thing I have remind here, there is no time at all. The main part in here is you have to take wind coefficients. I have already created a special sheet for this, but there is no time to show it to you. I have created a special sheet for this. There is no time now. It is already time is over here. So in next class, I'll also explain how to calculate wind coefficients according to IS codes and how to calculate wind and seismic pressures as per ASC codes also. Sure. Where is the chart button? Not this one. Is that?
Sir, I have a question.
Yes, please.
Sir, when we do drafting in AutoCAD,
okay, fine.
Like when we model the stats and give the property, it shows from center to the from center of column.
Sorry, just let me clear.
When we give the property to the line in a stat pro, it show in rendered view from the center of column, right?
Yes, exactly. Yes, exactly.
The after dimension.
Yes,
but
yes,
in
yes.
AutoCAD we have to provide the connection plate at the face of flange.
Okay.
Hope you got it. What I'm saying.
No, actually,
so how
the one thing you have to know. Yes, yes. Yeah. The one thing you have to know is all the dimensions. All the nodes we have to create a structure in the stat is along the center line only. Along the center line of the rafter, along the center line of the column only, it will take, and then it will be giving offsets to the either sides. Okay, so what is your doubt?
My doubt is the property we assign, like we assign the property of web is 350, suppose. So it will be at the center of column in a stat.
Yeah.
So same property should be at the face of column in AutoCAD. The depth of web.
Depth of web. Yeah.
In stat, yes, the depth of web will be at center.
Web. Yes, yes. I got your doubt.
If the depth AutoCAD, we do provide at the flange.
Yes. Okay. No problem. I understood your doubt. I'll show you one drawing here. Okay. So your doubt is nothing but, suppose this is the internal eye section I'm taking. Suppose let us take the depth of this web is in the plan it is showing, right? In the plan it is showing. So the depth of the web is, suppose let us take 400 and it is 200. So if it is going to the top, okay, so you have to take center line as the reference only. You have to take offsets 200 on either side only. You should follow like that only. Whatever you are following in the stat, you have to show in AutoCAD like that only. So the depth of the web is 400 there.
No, sir. My question is, when we do provide end plate, side plate connection.
Okay, end plate or side. Okay, end
plate. Yeah, this side, yes, sir. Yes, if we provide at the flange of column.
Okay, there may be two types of end plates. We can provide vertical splice and we can provide horizontal splice. Okay.
Right. When we do provide vertical splice, In STAT, the property is showing at the center of column.
Okay. Fine. Yes.
That property, how do we decide in AutoCAD? Where, how do we draw the same dimension from the center? Should we extend the line and then cut it, or the same dimension should be provided at the face of column in AutoCAD? I'm unable to explain exactly what I want to say.
Can I explain that doubt?
Okay, please.
Yeah,
explain.
you can go ahead.
Yeah, actually, if you take that STAD, it will take the center no sir frame. For example, if you give a web of 500, from the new center axis, it will be 250 above and 250 below.
Yes.
Whether STAD will see in AutoCAD when we design the thing, it will be either top or bottom. I mean, so how the whether what is the effect of that?
No, actually, yes, the size of the end plates is based on the depth of the rafter at haunch portion, right? The depth of the rafter at haunch portion, whatever the depth provided at the haunch portion, we can use somewhat higher than this one. So that will be calculated, that has to be satisfied the connection requirements. If the if suppose this is the 500, suppose let us take this rafter depth is 500. Suppose you got connection as 600, you have to take center line in the AutoCAD and then you have to offset 300 above and 300 below only, because you can observe here, suppose for example horizontal splice also there is some portion extending beyond the flange, so no problem at all, you can expand like this, no problem. This is right, you are asking?
No, sir, I was asking something different. Can you zoom out this drawing? What is the center to center distance of this column? So that I can explain better.
Actually, this is the proposal drawing. I have provided out to out distance here while designing the section at the base.
Sir, wait a minute. Zoom out. Please zoom out. Please zoom out.
Yeah.
The total clear distance is about 55 meter, I think.
No, yes, out to out distance. That is out of
distance.
Yeah.
When we draw the same thing in STAT Pro, we have to take from center to center.
Okay, exactly. Okay. That is the thing you are asking, right?
Yeah, I'm asking that.
I got it. No problem. Yes. Okay. So first you have to assume the base of the column. Depending upon the experience, you'll get all these things. First, you have to assume the base of the column. Generally, for simple buildings, generally it will not be more than 300 or 350 or 400. It may not be. In any case, generally for a pinned base, it may not be much than 400. So you have to assume that in your mind. So for 400, it will be for center line will be 200, right? So the STAT line will take from here only. Node will take from here only.
Yes.
So the block wall will be 200, and the center line will be, for example, if we take the column base is 400, so 200 plus the center line is 200. You have to less 400 on each side while giving the STAT Pro. Okay. Did you get now?
No, sir. Please go upside. Please go upside. There's a problem at upside. When we give the property to the column.
Okay, fine. I understood. Nothing. You are asking about tapered.
Yeah.
Yes. Yeah, I think I got. Yeah,
the tapered section show from the center to the column.
No. Actually, first one you have to give. You are seeing one thing right here. You are seeing STAT Pro.
Yeah, I'm.
So actually, we have to give at the stripe portion only. While starting the design, we have to give straight column like that. Nodes will have to be in one line only along y-axis. Okay. After designing, you'll get one section, right? Suppose I have shown here rendering view.
Yes.
So
this is my question.
This will be, suppose this is the top is 850, bottom is 300, right? So how you tapered will be done? 850 minus 300. Something I will tell you. Just a minute, I'll calculate. The system itself, there will be one calculator, right? Yeah. So 850 minus 300 divided by 2. This is 0.275. So you have to move this node from 0 level to 275 mm in order to get straight section like this.
No, my question is not that, sir. The if you see the rafter, please click on that so that I can see the dimension.
Okay.
This dimension is 816 at the face of at the center of column.
Yes.
But when we give the vertical splice in AutoCAD,
okay.
This 816 should be at the flange of column, right?
Yes, exactly. No problem in that. Generally, this is the one we are designing, but yes, you can give offset here. Just I'll tell you how to give offset. Suppose I'll show you here itself. Suppose this is the top is 850, right?
Yes.
Column top is 850. So this is at the center line. Here stat is connecting to the center line. But
yes,
actually in the practical, we can give offset some specifications. It will be there. I'll show you.
There is a
yes, offset command. Start is suppose shift T. This is 0.4 850, nothing but 425.
Half of column at the top, right?
Yes, exactly.
Sir, is there any change in results, sir, if you offset and?
Yes, exactly. There will be some saving. Sorry.
No, I mean, in design strength point of view.
Just a minute. Yes. Now you can see. I think like this only you are asking, right?
Yes, I was asking the same.
Yes, practically it will be done like this only.
Yes.
Yes, there will be some shaving. There will not be any strength reduction due to this.
After assigning the offset properties, should it will it affect the result?
Yes, of course. Of course. Why not? Just I'm running analysis here so that you can observe. This is your dot only?
Yes, it was out.
Yes, right? You can all are passing, no? No problem at all. In general, if you give offsets, the loading will be like this only. Generally, if the rafter, suppose I'm telling you the general concept, if the rafter continue to center line of this column, the load will come also here, right? But if
yes,
you are offsetting the rafter, the load will not come here. So this portion of the load will be reduced. Thus, there will be some decrease in ratios. No,
it will become more economical.
Yes, exactly. There will be some decrement in the ratios, and you'll get more economical section. So while generally, while doing mezzanines, we have to use this concept, because mezzanine loads will be much more higher, right? So we have to use this concept only in order to
create more momentum.
Yes, exactly. Yeah. Any other thing?
Sir, one small question, sir. Like, see, for example, now we are considering this in STAT doesn't consider horizontal knee connection or vertical knee connection. So we will get only moments at the nodes. I mean, which connection do you prefer? Means we need to prefer for practical. I mean,
so practically, you mean to say you're asking about bracings or something else?
No. Connection between column and rafter, sir. Vertical, horizontal connection or knee connection and horizontal knee connection.
Just a minute. At this portion.
No. At you, sir. Column and rafter.
Yeah, at you. You're asking about?
We can go for a horizontal connection as well as vertical connection, no, sir.
This one,
yes, sir.
Yes, yes.
So, like, see, instead, it will give all the moment, no, it won't give, like, we cannot find which connection to be.
No. Actually, there is one thing we have to provide. Generally, vertical splice. Just a minute.
This is horizontal, no, sir.
No. Only one vertical splice we will not provide generally. So generally we will provide vertical splice if there are multiple numbers like this. Okay. So we'll generally we'll provide horizontal only. If there are multiple numbers of splices, we can provide vertical only. Why they are following like that, I don't know, but they're doing it for some reason. Yes, exactly.
No, sir. Now at this column and rafter joint, can we provide a vertical knee connection?
Yes, I mean you are asking
yes.
rotate this at this.
Yes, sir.
Right?
Yes, sir. Yes,
Yes,
sir.
we can provide. No problem at all. No problem.
Okay. Is there nothing will be affected? Like
No. Nothing will be affected.
Same like moment we can take in both cases.
Yes, of course, because STAD will take center line only. No.
Yes, sir. Yes,
This
sir.
will only. So the same moment will be transferred from rafter to column. So whether you can take here, no problem at all.
Okay. Some people will ask to go for with the horizontal connection only. That's why.
Yes. Probably more shear you will get here. The vertical shear you will get more here. In the general idea of the people. Actually, there are no thing like that. If you get more shear, the rafter will collapse like this, right?
Yes, that's what they
like that, right?
Yes,
if it is resting on the column, there will not be any problem. The most of the people will think like that, but there is no scientific reason.
Okay, so we can go any connection.
Yes, sure.
Yes, sir. That's what some people will say. Don't give.
Yes. Some people fear about rafter. If connection here fail, no, the rafter will collapse directly here.
Yeah, that's what then.
So
I got it.
If it is like this, rafter stand on the column itself, right?
It will seat properly there.
Yes, that's what people think like that. Some people think that. No problem. Yes. Any other thing? Right. We can conclude now. Any other? Shall we design PEB structure in E-tabs instead of STAD? Yes. Why not? We cannot design in E-tabs. Yes, we can do it for sure. And please share STAD Pro download link. So no, sorry. This is I will not encourage in doing this one. I mean to say cracked versions. I will not encourage like that. You can search it in Google if you want.
Sir, you will explain
non-commercial portion. Yes.
Sir, you will explain CPE minus CPI area into PZ next class.
Sorry?
When our building is closed from all sides, the wind calculation will be different, like CPE minus CPI area into PZ as per IS 75. You will explain that?
Yes, for sure. Actually, I have to explain in this class itself, but there is no time now. Actually, you can see I have prepared one Excel sheet here for that also. Just have drawn this thing to explain, but there is no time now. It's already time out. That's why I stopped, because it may get stopped in between the time. That's why I stopped it. Surely. There will not. We cannot apply direct entire wind into the frame. There will be some coefficients. External wall coefficients, internal wall coefficients. We have to apply net wind pressure. How to apply net wind pressure, and what are the directions? And there are sign conventions, plus and minus. How to use plus and minus? In STAD Pro, how they get different? Yes.
Till now that we have learned of wind calculation, that is only for open structure like canopies, right?
No. That is, I just told you that wind calculation only, wind pressure only.
Yes,
I told you just wind pressure only. I did not tell anything about this thing, wind coefficients. I'll tell you. For there are different for enclosed buildings, partial enclosed buildings, open buildings, some single slope and canopies, etc. There are much more things you have to learn.
Okay, sir.
There are different types of wind coefficients for different types of structures. You'll see. Yes. Yes. Any other thing? So yes. If a building is at confined space having all direction larger building, yes, wind direction applied or not. Just I told you there is terrain category 4. You have to apply terrain category 4. You have to apply wind pressure on the steel structure for sure. There is no concept of not applying any wind pressure on the steel structure. You have to apply wind pressure for sure, but you have to take terrain category 4 in that case. How building is open from all side, how to design wind speed. There is no change in wind pressure calculation, but only there is change in wind coefficients. You'll get roof coefficients higher in winds open building. So I'll tell you. Could you see my question above this one, Rajeshekar? Where is Rajesh? For admin buildings at the toll gates and the highways, which wind category we have to consider? Which wind category you have to consider? One or two? The critical one, because this is the road communication. It comes under communication, no? Right? The vehicles should not stop in any emergency services. So we have to take the critical one. Okay? So no problem. Whatever the higher factor is there, we have to take that one only. It will come under emergency service only. Highways and always comes under emergency services only. And how, sorry, explain when and how additional factor for coastal area is interpreted. Explain when and how additional factor for coastal area. Okay, fine. This is the thing I think you are asking about. Where is that? Oh. Just I'll see. There is one thing I want to tell you. Is that? Yeah. Class 6.3.4, no? So you can see here importance factors for cyclic region K4. Okay. You have to change this one only. Generally, structures of post cyclone importance factor, all these consider K4 is 1.3 in that case you are asking about. Something related to coastal area, you have to take K4 as 1.3 in that case. Okay. And something class 6.6 you are asking about. Okay, fine. Yes, exactly. The wind pressure will be multiplied by 1.15 times of the general area. Whatever you are designing for general wind speed, you have to multiply it with 1.15 times. Suppose we have to take K4 value as 1.15. Here, this is the importance factor for cyclonic region. That is what I'm telling. For example, if we are calculating K4, we have to take 1.15 at the coastal areas. Something. Any other thing? Clear, I think. Okay, I think all of you got. This is in addition to. No. Generally, in addition to K4, why we have to take? Yearly, for any other structures, generally we are designing. We have taken example, right? Sorry, we are taking example for industrial warehouse. This is one exactly. So 1 plus 1.14. Sorry, 1.15. Yes, 2.15 you have to take, right? K4 is 1.15 here. In order to impart coastal importance, we have to add this 1.15 to the regular K4 value. Like K5, No. K5 1.15 you cannot take. No. K4 itself only 2.15. Okay, one is general for all buildings. If any structure is, suppose if it is a hospital, I'll tell you. Suppose if it is a hospital, 1.3. In addition to K4, has clearly mentioned in addition to K4, 1.15. So 1.15 plus 1.3, 2.45 you have to take. No, you cannot multiply 1.15. No, 1.3 plus 1.15, that is 2.45. No, not 1.45. Yes. So how and when to use, like, yes, customer clearly has to give this one. Client has to give, because client has to give. Suppose if we take, suppose a city like Vizag, a city like Vizag, in addition to that, the influence of the wind speed of the coast up to distance of 200 km, coastal areas up to 200 km. Maybe I did not get anything projects in these areas till now. Probably I am thinking that there are a certain range. Suppose, for example, 200 kilometers from the coastal region, you have to take 1.15 in addition to 1.1, or in addition to regular K4. It's in the board, sir. Sets are not emergency any services, no. Those are all regular structures. 1 plus 1.15, 2.15 you can take K4. Fine, okay. You have any doubts, please note it down and I'll clear all about. Up to my knowledge, I'll clear all the things. And if you have any doubt beyond my knowledge, damn sure I will clear you after I'll take reference from my seniors. Surely I'll help you. At the end of the complete this course, you'll get everything, okay, related to PEB, how to design a frame, how to design a bracing, how to design a cold form section, everything you'll get for sure.